Hello, in this video we will entertain the concept of nomenclature of ionic compounds. Okay, so again we will look at the conventional way to do it, and then my advice would be to look at a list of already solved names and just get some muscle memory of learning what they look like. But before that, let's look at a conventional way to present them. So the conventional way to present them would be take your ionic compound, so what do we mean by ionic? Well, it can mean lots of things, but typically it's a mixture of metal and non-metal, although not always, but typically. All right, so we take our ionic compound, and then we separate it into its ions. The periodic table presents with metals on the left, so it would make sense to write the ion from which the ion that comes from metals, which are cations. So you have your cations on the left, your anions on the right. Remember, the anion is the negatively charged ion, the cation is the positively charged ion. Now, we have a little bit of variety. On the cation end of things, some cations are, like in the S block, for example, they have a constant. I think constant might be the wrong choice of word. I'm not going to say constant. I'm going to say fixed. Actually, is fixed the word I want to use? No, I don't think that's right either. I'm going to say single charge. Single type of charge. That's wordy, but I think it's what I want to say. As opposed to variable types of charge. So the S block metals, the first two groups of the periodic table, they are single types of charge, either +1 or +2. There are other types of elements that are single charges, but exclusively the S block has the single charges. A couple of D block and P block here and there. But for the most part, the D block metals and the P block metals can have a variable type of charge, more than one type of charge, which we'll see. If you are a cation with a single type of charge, we just go ahead and name you. Same name as the element. Okay. If you are a variable type of charge, we have to specify which charge you are. So we give you a name, same as the element, and we also have to give a Roman numeral. So we're going to learn to write Roman numerals, just the first 10 numbers. And essentially the Roman numeral specifies the charge. We don't need the Roman numeral for a single type of charge because there's only one type. But there's a choice if there's a variety possible, and we have to lock down the choice taken. Okay, the anion can be monatomic or polyatomic. We can actually, now I think of it, we can also have polyatomic cations, But there's only one that really springs to mind that we'll need to worry about. So rather than write it as a general rule, we'll have it as an exception to the rule, and I'll be sure to point it out. Or your instructor will point it out at some point, whoever she may be. Okay, polyatomic. If we have a monatomic, that means one atom that hosts the charge. We would have a root and the suffix IDE. If it's polyatomic, it will have a unique name that you're just going to have to learn. That would be the sage advice. Okay, so this is a typical way it's presented. Let's look at those Roman numerals and then we'll see our first example. So I'm going to write down the Roman numerals here that we would have to learn. And they are for the numbers 1 through 10. And they would be I, I, and then 5 is V, and 4 is 5 minus 1. So we put the 1 that we're going to subtract from the 5 on its left, so it's IV. So again, 5 is V, 4 is 5 minus 1, so we put the thing that we're going to subtract on the left. 6 is 5 plus 1, so we put the 1 on the right of the V, so it's VI. 7 is 5 plus 2, so it's VII. 8 is 5 plus 3, so it's VIII. 10 is X. 9 is 10 minus 1, so it's IX. Okay, and they're the first 10 letters counted in Roman numerals, and they would represent the charges. So a plus 1 charge, you would have the name and then I. A plus 5 charge, you would have the name and then V. Okay, so let's look at our first example. Okay, let's look at, let's see, our first example. Let's see, what would be a good one to start with? Yeah, I'll just start with magnesium bromide. Okay, so let's start with MgBr2. Okay, so we're going to look at the cation and the anion separately. The cation here, it happens to be a constant charge because magnesium is in group 2, it's an S-block metal. So it's a constant charge, so we know it's going to be Mg2+. And the anion in this case is bromide. That's monatomic. It's just going to be Br-. I have a separate video on predicting charges, so we won't go over that here. We're just interested in naming. So this is constant charge. So we would just name that the same as the element. Magnesium. This is a monatomic anion, so it has a root, brom, and then the suffix "ide". Notice there's no prefixes here. Although there's 2 bromides, we don't use prefixes when we name ionic compounds. So it's just magnesium bromide. So again, crucially important step. We have no prefixes. And if you understand the charges, we don't need any prefixes. You know with ionic compounds, they must sum to a zero net charge. And if you know the charges of each ion, you know how many bromides there must be to quench the +2 charge on magnesium. So the prefix is not required. Chemists are smart people. We don't need to be told, hey, there's 2 bromides. It's like, I know, now leave me alone. Okay, what if we have variable charge ionic compounds? Let's have another example. Variable charge ionic compound. Let's look at something like Fe2O3. So this is a D-block metal ion. So we're going to have variable charges. So let's go. We have a variable charge cation. Now, how do I know the charge? Well, I know that the whole thing must sum to 0. So I know that whatever the charge on ion is, so let's call it X, I know there's 2 of them, right? So there's 2X. And I know there's 3 oxygen. And I know oxygen likes a -2 charge. And they must sum to 0 because it's an ionic compound. So I need to solve for the variable charge, right? So I've got 2x minus 6 is 0. Take the 6 to the other side. So I've got x is +3. So that's my charge in this case. So I know I have ion 3+. That's the choice out of the variety. It could have been ion 2+, it could have been something else. But on this occasion, because of the ratio, this 2 to 3 ratio between ion and oxygen, I know it's ion 3. So I can write the name ion and then the Roman numeral, which in this case is 3, which is III. Okay. And on the anion side, I've got O2 minus. That's the charge on oxygen. So I've got the prefix, not the prefix. I have the root, I guess we call it the root, which is ox for oxygen, and then the suffix IDE. So when I combine those all together, I get ion 3 oxide. Okay. I don't just have iron oxide, I have iron 3 oxide. Notice not a prefix in sight. So if that's iron oxide, if that's iron 3 oxide, let's have a look at another type of compound that has iron and oxygen. What about FeO? Here's a different ratio. So between these 2 compounds, this is a multiple of proportion, so that's definitely not this video, that's another video. But let's see what the charge on this guy would be. So here, I don't know what the charge on ion is, it can be variable. Let's call it X. But X plus a single -2 charge on oxygen equals 0, the charge on the ionic compound. So here, X minus 2 is 0. Take the -2 to the other side, X is +2. So I can immediately tell what this is going to be, but let's not spoil our fun. Let's go through the motions. I know it's Fe2+ because that's my variable charge. So this is going to give me ion Roman numeral 2. And then this is going to give me O2 minus, which is the root ox and the suffix "ide." So when combined together, this is iron 2 oxide. So clearly the Roman numerals are vital. You can't just say iron oxide, because then which one do you mean? Do you mean the one with a 2:3 ratio or the 1:1 ratio? So by stating which charge is present, everything is good. Okay. What about, to finish off this video, let's look at examples with the polyatomic anion. And my advice here would be to get a good list of polyatomic ions and just learn the names of them. Just memorize the names. There's really no shortcut around that. Let's look at, what if we had Cu NO, which one should we have? Yeah, let's have CuNO3 twice. Well, first we notice that we have a polyatomic ion because it's a multiple and it's in parentheses. So that means I have one Cu and I have two lots of this thing here, which I would learn the name of. Alright, so let's split this up. So we have our variable charge metal. Now on this occasion, let's assume that you've already learned the polyatomic anion charges. So you know that this thing in the parentheses has a -1 charge, and there are two of them. So I must have copper 2. So copper Roman numeral 2, because that's the charge. And then my polyatomic anion here is NO3, and you're just going to have to learn that that's called nitrate. It's a T. Okay, so we have copper 2 nitrate. And again, in a video, it's not a great use of a video just to go through every example that you need. But I would strongly encourage any student to go online, search for nomenclature practice problems, and you'll find pages and pages of solved names. Just follow these basic rules and learn how to do them yourself. And I think that will wrap up this video.